Alright, so here's a lesson that I forgot to, or not forgot, I ran out of time with you guys, so you should be doing this on Monday. It's for lesson 28, which is triangle congruence, using the side angle side postulate. So going over a couple definitions here. I wrote them down for you. The first one is the an included angle. An included angle is just an angle that's formed by two adjacent sides of a polygon. Okay, so for instance, an angle formed by two adjacent sides. So two adjacent sides are sides that are right next to each other. So for instance, DC, this side DC and the side CB are right next to each other, and the included angle would be angle C. Okay, so it's an angle formed by two adjacent sides. So here's one side, here's another side, and the angle is C. For sides DC and DA, the included angle would be angle D. Okay, so that's pretty easy. The included side, an included side means, the definition means the common side of two consecutive angles of a polygon. So if you take two angles, let's just take angle A, and angle D. Okay, so these are two angles. We're going to take the common side of those two angles. So that would be side AD would be what's called an included side for those two angles. Okay, so let's look at, with that, we're going to look at example number 1, which says, what is the included side of angle A and angle B? Okay, so let's just take this off over here. Let me do it in a different color so we can see. Okay, so what is the included side of angle A and angle B? Okay, so the common side that they both share is side AB. So segment AB is the included side. The second part of that question asks, what is the included angle, and I'll do it in a different color as well, of what is the included angle of sides BC and CD. So side BC and CD, what angle do they form? Is angle C. So angle C is the included angle of sides BC and CD. Okay, so that's pretty easy, I hope. Let's move on to the next page, which is page 176. All right, in example 2, we have we're using the side angle side postulate to determine, oh, we didn't discuss what the side angle side postulate is. The side angle side postulate, okay, side angle side postulate, and this is for triangle congruence. Okay, so all it says is that if two sides and the included angle, I don't know why I'm writing this down, but for some reason it helps me to remember it, and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Then triangles are congruent. Okay? So that's all it says. And they're congruent by what's called the side angle side postulate. Okay? So now let's go ahead and go to example number 2. And I will recreate it on here so that you can see. It's two triangles. Okay. So we have two triangles. And we have this tick mark. We have this tick mark here, so these two sides are congruent. Then we have this angle is the same as this angle. Okay? The question is, determine whether the pair of these two triangles are congruent by the side angle side postulate. Okay, so let's take a look. So these two sides are congruent. This side's congruent to this one, this side's congruent to this one. However, the angle that they are, the angle on this one is the included angle of these two, but it is not, on this triangle, it is not the included angle. This one is not formed by this line segment over here. So the answer to this one is no, or not necessarily. So the answer would still be a negative. No, not necessarily. Congruent. They could possibly be congruent, but not by the side angle side postulate. Okay, so because it's a different angle that is congruent to this one, we don't necessarily know what this angle is, and it's not the included angle. So the answer would be no. Okay, and let's look at example 3. It says find the missing angle measures. Find the value of x that makes the triangles congruent. Okay, so we're looking at two triangles. I'm not going to really try to replicate them exactly. So I'm just going to draw two triangles with the formulas that we have. Okay, so it shows that this angle here is congruent to this angle, line segment, and these two line segments are congruent. However, this line segment is represented by 6x minus 27 degrees. And this line segment is represented by 4x plus 7 degrees. So we have to find the x to make the value, to make these two triangles congruent. Okay, so let's go ahead and put it into an algebraic form. So 6x minus 27 equals 4x plus 7. So we can just add 27 to both sides first. And 27 is 34. Then we can bring the 4x over here. So we have 2x equals 34. X would equal 17. Okay, so I hope I didn't go too fast for you guys there, but so the answer would be x equals 17. In order for these two sides to be congruent, x would have to equal 17. Okay, all right, so now let's move on to example 4, and this will be our last example. All right, so we're going to use the side angle side postulate in a proof. Okay, so I'm going to recreate this because I reviewed it earlier and it's a little tricky to follow, so I want to make sure I go over this kind of carefully with you guys. Okay, so we have two triangles that make kind of an X. Okay, so let's just form. Okay, so there's okay, and the two triangles that we're looking at, let's give these points A, B, C, D. Okay, so the question gives us a given. First of all, we're going to use the side angle side proof to write postulate to write a 2-column proof. The given that they're giving us is that AB, side AB is congruent to side CD. Okay? And they want us to prove that triangle ABD is congruent to triangle DCA. So let's go ahead and outline those with different colors so we can see them. So triangle ABD is this one here, ABD, and triangle DCA is DCA. However, I didn't mention that they are giving us that angle D right here is a right angle, and angle A is a right angle. Okay, so for the proof, we have the first one is we're going to write down the given. So AB is congruent to CD, and that's given. Okay, number 2. Actually, the other part of the given is also that angle A is and angle D are right angles.
Putty stuff.
Okay, that's all part of the given. Number 2 is we have BD, triangle BDA. The measurement of angle BDA